Welcome. Today we're going to talk about the business value of continuous integration, continuous delivery, and DevOps with application security. More importantly, how to scale up your product and service delivery life cycles to multi-billion end-user global systems of systems using containerized microservices. Feel free to visit my website where you can get this brief, watch my lean and agile videos, and get my great white papers on how to apply these to extremely large systems. Once again, I've been a U.S. government contractor for the better part of 3 decades. My background is in computer science. I'm a career systems and software engineering methodologist. My first project was NASA's space station, and of course I published the first textbooks on the ROI of CMMI and agile methods as well. By now, most of us have heard of the Internet of Things, which is a dinosaur killer with tens of billions of devices connected to the Internet, soon to be trillions, billions of mobile phones, Amazon, Yahoo, Facebook with 2 or 3 billion end users each. That places extreme pressures on today's product and service delivery life cycles, making this a legitimate extinction level event. DevOps has emerged as an answer to this extinction level event, which is an early, iterative, and automated combination of both development and operations based on principles of lean thinking, product development flow, and agile values like collaboration, teamwork, iterative development, and responding to change. It's really a family of popular techniques that, when used in combinations, help increase business value. So how does DevOps work? Well, in the DevOps paradigm, requirements are implemented in slices versus layers. Rather than implement overscope systems using traditional methods, fewer higher value requirements are implemented first, one at a time. And when you do this, it speeds up the delivery lifecycle, increases business value, but more importantly, it reduces risks, defects, performance bottlenecks, as well as security vulnerabilities. At its heart, DevOps is a lean and agile practice based on one-piece workflow. Therefore, we can use visualizations like cumulative flow diagrams to illustrate how it works. If you have overscoped systems with too many requirements, it increases bottlenecks, reduces productivity, and reduces quality. However, when you implement your requirements in slices versus layers, it actually reduces lead times, improves cycle times, and improves quality. Over the last 20 years, a family of techniques has emerged to help us reduce the risk and increase the success of product and service delivery, such as minimum marketable features, minimum viable products, and even minimum viable architectures, which, when we reduce the scope, the cost, the risk, the size, it increases testability, quality, reliability, security, even team morale, system maintainability, and ultimately success. The secret sauce to the information technology revolution is clearly the notion of microservices, which are small autonomous services. Rather than building over-scoped applications using traditional paradigm, we build much smaller applications, and we tightly wrap them in containers replete with the image, the middleware, and just enough operating systems. We test them, and we secure them, and we deploy them to billions of devices in fractions of a second. The DevOps revolution didn't happen overnight. It's rather an evolution of closely related concepts like lean and agile methods, concepts like test-driven development, continuous integration, behavior-driven development, continuous delivery, DevOps, and even application security and microservices. Once again, this revolution or evolution started with agile practices like test-driven development, where small extreme programming teams pulled user stories off the backlog one at a time in one-piece workflow. They first wrote their tests, then they ran the tests, then they wrote the code, and then they reran the test and refactored the code, working out the waste, and then tested it and delivered it to the end users as quickly as possible. This slide illustrates the basic test-driven development concepts. Take the user story off the backlog one at a time as a small pair programming team. Clarify it, understand it, split it, right-size it, write the acceptance criteria, develop the tests, run the test, write the code, rerun the test, and then refine the code to its smallest waste-free state. Another closely related practice is the notion of behavior-driven development, whereas TDD focused on rapidly coding and testing user stories or software units one at a time. Dan North realized the necessity to write tests and for larger groups of user stories called features, and this is a less frequent process, so TDD cycled faster while BDD cycled a little less frequently. The BDD process is very, very similar to the TDD process, except that you look at the feature statements one at a time, you try to understand them, you write the acceptance criteria for the features, you develop the feature tests, you run the feature tests when groups of user stories are complete, and you continue refining those features and refactoring until larger groups of user stories function or satisfy your tests. Beyond the advent of lean and agile methods and practices like extreme programming and Scrum, TDD, and BDD, the next major evolution or revolution in this saga was clearly the advent of continuous integration. As programmers pulled those user stories and features off the backlog, wrote those tests, and that they checked them into the version control server where millions of tests were automatically run, kicking back the erroneous code back to the developers for further refinement, or if the tests passed, they were actually installed on local hosts or delivered for further independent testing. Let's examine some of these continuous integration practices that are very, very controversial even today, 20 or 30 years later. We have the automatic building and integration of the code, the building of the databases, the automatic static analysis, the automatic testing, the automatic feedback to both developers, end users, and project managers, even automatic document generation and automatic deployment. So far, we've talked about the evolutionary or revolutionary practices like lean and agile methods, Scrum, extreme programming, TDD, BDD, CI, but a small variation of this is continuous delivery, whereas continuous integration focused on test automation, continuous delivery focused on the final packaging of the product for independent testers or delivery to end users, historically representing 80% of the development cost. Let's quickly examine some of the value-adding practices of the continuous delivery paradigm, the packaging of the software or the system for final delivery, any automated acceptance testing, load testing, performance testing, any pre-production testing, any certification testing, and any pre-deployment testing if necessary. Once again, very controversial, somewhat subtle, and reduces a lot of cost and defects. Clearly, the next major revolution in this saga was the advent of development operations or DevOps, which recognizes the existence of the development organization as well as the IT operations organization and the collaboration necessary to develop and deliver the product to the end user. So everything we've talked about so far focused on the development community. Now, DevOps really kind of focuses on what the operations community has to do. Let's examine some major DevOps activities like system administration, configuration management of assets, host builds, virtualization, containerization, deployment, monitoring, and support. When you can standardize, simplify, debug, automate, and even push some of this back into the development stream, then you can reduce your costs and increase your speeds by orders of magnitude and deliver your Microsoft services to billions of global end users in fractions of a second. As we've painfully discovered over the last 2 or 3 decades, when you deploy your IT assets to billions of global users, security becomes a major issue. Thus, DevOps security comes front and center, which is a triad of security engineering, secure microservices, and secure operations. That is, you must engineer your assets to be secure from the inside. You must secure your containers to internal and external penetration. And of course, you must monitor your global IT assets. So let's look at some basic DevOps security practices, such as engineering the applications in a secure way. That is, you must bake in your security, not ice it on the end. You must have secure containers. You must evaluate those containers. You must deploy them in a secure way. You must protect them while they're deployed. You must monitor them, and you must provide an adequate security response. Edward Pound, author of Factory Physics, astutely observed it's not enough to have automated one-piece workflow. You must wrap your DevOps ecosystem or pipeline in a tightly integrated system of lean and agile portfolio management, large solution management, program and project management, and even team practices. The Scaled Agile framework is just such a lean agile framework which has emerged to support this type of a paradigm. Software development automation has always been viewed as somewhat of a silver bullet since the software factories of the 1970s and the case tools of the 1980s. But we've talked a lot about automation, so let's examine some of the tools within the DevOps ecosystem. Obviously, there are tools for computer programming and committing, building and configuring, scanning and testing, and even doing release and deployment. Today's information technology stacks have become unnecessarily complex, and with that, literally thousands of DevOps automation tools have emerged. Xenia Labs has done a nice job of creating this periodic table to classify them into database, continuous integration, deployment, cloud tools, monitoring, configuration management, and so forth and so on. Nonetheless, this remains a very, very complex problem that's sort of hindering the proliferation of DevOps. We've also talked a lot about DevOps security, so let's examine some of the security tools, that is the basic ones. Obviously, there are basic security tools for the coding process, the configuration management process, and storage and building and integration, as well as deployment. Much like the Xenia Labs periodic table of DevOps tools, the SANS Institute has also constructed a secure DevOps toolchain with security analysis tools for the pre-commit stage, for the commit or continuous integration stage, the acceptance or continuous delivery stage, the production or continuous deployment, and operations. Definitely Google the SANS Secure DevOps toolchain poster. It's free on the internet. Let's examine some basic DevOps metrics. Obviously, test coverage becomes very, very important. Over 70% of code is dead code or unreachable, so test coverage will tell you how much of it has been tested. Obviously, test automation becomes key to increasing test coverage, and obviously you want to increase your number of integrations and builds because this drives down defects and solves problems earlier. But when you combine all this coverage and automation and integrations, it actually increases your delivery speed. While the previous slide focused on internal or black box DevOps metrics, this slide focuses on external or white box DevOps metrics like deployment frequency, change volume, lead time, failed deployments, mean time to recover, customer ticket volume, and all these become extremely important to monitoring the effectiveness of your DevOps deployment. Remember, as we said before, traditional teams, over 80 to 90% of their development costs are in manual operations, but when you deploy and employ lean and agile practices, including DevOps practices, you flip the cost of quality upside down, increasing your return on investment by thousands of times. That is, the cost of developing and actually verifying and validating becomes fractional so that you can actually deploy your assets thousands of times faster. This is a real-world DevOps case study by Hewlett-Packard where they reduced their build times, increased the number of their builds, reduced their feedback cycles and their testing costs, fractionalized their development costs, freeing up 80% of the resources for new products and services, innovation, and return on investment and revenues. There are actually 3 .com DevOps studies on this slide, one by Assembla where they increased the number of their deployments from 5 to about 50, which is where Facebook is. Google runs about 120 million tests per day on their entire product line, and Amazon does nearly 136,000 releases a day to their baseline. Remember, the average length of a U.S. government project is about 8 to 12 years, so this is literally thousands of times faster. This is a fascinating Blackboard case study where they were integrating their code into one massive ball of yarn, and their productivity actually dropped to 0, and their quality actually got worse. But once they sort of broke up their architecture into microservices, once again their productivity took off, but so did their innovation as they freed up their development resources to focus on new higher value adding products and services, as well as reducing operational costs and increasing profits and revenues. This is a fascinating DHS DevOps case study where they continuously refactored their development lifecycle over a short period of time to reduce the release time, reduce their documentation, reduce their gate reviews to achieve world-class performance where traditional teams want to slow the process down, increase their documentation, and increase their gate reviews, which actually worsens quality. This is a late-breaking ROI study by DevOps Research, or DORA, which is on par with everything we've described here today, exhibiting the fact that medium-sized organizations who use DevOps can immediately get $66 million in benefits on only $1 million in cost with a 5,000% ROI in only about a week. Well, DevOps is used 100% by big .coms like Apple, Google, Yahoo, Facebook, Amazon. For other Fortune 500 firms, it's a little bit slower. Right now, it ranges from about 20% to about 35% in terms of DevOps adoption for small to medium-sized firms. Here's a simple but effective DevOps implementation roadmap, and it suggests that organizations and projects should focus on simple build and integration tools and processes, move into the heavier duty testing processes, and finally into the more sophisticated automation and deployment and security monitoring process. Of course, all of this assumes you have a strong foundation of lean and agile practices. The DevOps Research, or DORA group, does some very, very sophisticated organizational DevOps assessments, and they measure your team's performance in terms of IT performance, your lead time, your deployment frequency, your mean time to failure, your change failure rate, your even morale metrics like your burnout rate and your deployment pain as well. Here are some simple but powerful keys to DevOps success. Obviously, everything begins and ends with lean and agile principles. You must downsize your portfolio. You can't develop everything in the world. You must simplify your systems architectures, modularize your interfaces, use microservices and end-to-end automation. But everything hinges on leadership, from top leadership, middle management leadership, project managers, and technical leaders within. DevOps does not mean deliver it now and fix it later. It is a lightweight yet disciplined approach to development to reduce your cost, risk, and waste while improving quality. You must involve your customers early. You must scope your complex programs, divide the remaining work into smaller batches, work in small cross-functional teams, and obviously incrementally test and regression test your microservices as you develop and deploy them. What's the bottom line on DevOps? Well, DevOps ensures enterprise success by helping your firm or organization deliver large volumes of valuable, reliable, and secure IT products and services to billions of global end users in fractions of a second, just like Amazon, Yahoo, Google, Apple, Microsoft, Facebook. You can't survive in the 21st century without it. It's an extinction level event or a dinosaur killer. Please remember to visit my website, davidfrico.com, to learn more about me. Grab my Lean and Agile briefings, including this DevOps briefing. Watch some of my videos, and obviously grab my white papers on how to implement these practices on large and complex programs.